Good morning, everyone. This is going to be the first talk, right? Yeah. Welcome, everyone, and straight to the topic. So, myself, Jobin, I am regular face here in PGConf. And this year's topic is external proxies and poolers, a reality check. So, this is a bit controversial topic because we may have to rethink some of the things which we were doing all these years. Because, the technology is not stagnant. Things are keep moving. Everywhere there is improvement. And we cannot stick our design or architecture to some of the things which we were doing in the past. So, there are a few old narratives. We need to reevaluate many of them. And some of the technology changes we need to think about. And where are the current bottlenecks? So, unless we know that, we can't fix the problem. And there are some limitations with our human perceptions, which is affecting that. I came to that later, that I realized that later. And some of the real world customer cases and reconsideration of proxies, all those things happened in my day-to-day life. So that also add to this talk. So I feel this important talk or topic someone should consider, especially in today's technology stack. And I'm going to touch upon some of the major things, the existing PostgreSQL culture, and the 4 major values which everyone will be considering, say business values: performance, security, availability, and maintainability. So if you are a DB or a database manager or architect, these are the business values you are expected to deliver, or the business is expecting from you, and how these external proxies and poolers plays here, whether we are adding value or diminishing the value. And there are some positive bias that happens always, and learning from incidents. So these are the topics I want to cover. And first, the PostgreSQL culture, the existing culture. So if you look at a lot of blog posts, discussions, architectural diagrams, this is what we see generally. There will be poolers, and in this case there are PgBouncer, and additionally there is HAProxy, and then users are going through all these layers and reaching the database. One thing we need to remember is we don't see this kind of chain anywhere else. Say you may be dealing with Oracle or other databases systems like SQLServer. Generally, we don't see this kind of chaining there using external stuffs. And this is not isolated case. We see across different architectural diagrams. So if you look at the internet, you'll see a lot of things. So in this case, we can see HAProxy, and there is a keep alive for managing the virtual IP. So a stack of things are formed until the connection reaches the database, and that is PgPool stuff. So there is also additional overhead there. Yeah, so this is a general practice in Postgres. If I look at many of the LinkedIn posts, discussions, everyone vouches this. So for today's talk, the external connection pooler means a proxy from application perspective, not from the database perspective, because it is the application which takes the connection and releases the connection. The connection always owned by the application. Application makes the connection. So a proxy is from the application perspective, and the application establishes that connection over the network. At least even if it's running locally, there could be TCP stack forming, and again it need to do the authentication. The proxy cannot accept everything coming in, so application need to keep authenticating. And when we look at the pooler, these are the values we are generally expecting from a pooler. Connection multiplexing. So multiplexing means a single database connection will be used by lot of application sessions. So hundreds of application sessions using one or two database sessions. That's called multiplexing. Another is queuing. Queuing means incoming connections need to be served in the order. So first come, first serve. So that is queuing. And pre-authenticated connections. So every time the application need not do the authentication, because authentication is overhead. And there is other problems also. And connection routing. These are the values we expect from a pooler. And the first major value, the performance we need to look into. And when I discuss this with many of the end users and customers, what I came to know is there is a lot of misunderstanding about the latency. People do say we have a wonderful network. So because people measure the network in terms of the transfer volume, so they say Gbps or TBps, that is the measure they say. No one tells what is the latency. And actually what hurts the database is the latency. Not, see, even if you have Gbps network, latency could be high. And the number of network hops it need to make. So all these things affects. So and each hop there will be additional processing involved. And some decision making like a routing will be happening. So all these things need to be considered instead of just the entire bandwidth. Bandwidth is only one factor. And there is limitation in human perception also that is affecting all these decisions. Because when I discuss with the people about the latency, they think everything is very fast. So generally people say everything is fast, everything happens in milliseconds. So for a human perspective, millisecond is really fast because we cannot perceive that, what is millisecond and what is nanosecond. So for a human being, millisecond and nanoseconds are very fast. But actually there is a huge difference between a millisecond and a nanosecond. For a comparative knowledge, in a nanosecond, light travels 30 centimeter. And the modern computing infrastructure like a CPU, memory, everything happens in nanosecond range. So that fast. But in a millisecond, light travels 300 kilometers. So where is 30 centimeter and where is 300 kilometers? So that is a difference. That is what going to affect our database performance. So whenever somebody says it's really fast and in terms of milliseconds, in computing world, millisecond is huge. You know why this human perception is because our neurons are slow. That is why the visual perceptions and audio perceptions are so slow. And latency impact when we study. So this is the slide which I presented last year because I was talking about modern SQL. And just look at these numbers. Latency average is 0.017 millisecond. If we have such a high, very fast network, low latency network, the Postgres can give 60,000 queries per second. Just imagine, this is from a single database connection, 60,000. So at the server's side, there is no problem. It is really wonderful. And what happens if this latency slightly increases? Say it increased to 0.028. The queries per second drops from 60,000 to 35,000. Huge impact. And so I done a comparative study by increasing the network latency. Say 60,000. So people say it's a very fast, 5 millisecond. It comes to a 3-digit number. So this is the impact of network on your database performance. So today morning, my friend Lalit was saying, everyone talks about tuning the server in terms of SQL tuning. So they directly go to the SQL tuning layer instead of looking at the infrastructure, whether these latencies are happening or not. So if these latencies are happening, there is no point in working on SQL tuning. So first, this infrastructure need to be corrected. And the graph looks like that. So from 60,000, you can end up in 2-digit numbers. And yeah, this network latency is not something unknown to everyone. Say most of the cloud vendors knows this because it is affecting their infrastructure. And there are a lot of papers, and they're trying their level best. So I tested in some of the best cloud infrastructure, and there the latency is, which I could get, is 0.2 millisecond. And this is the queries per second for the same test. So if anyone want to experiment with this echo test, say you can use a PgBench. How the latency plays out. You can just use the PgBench to send some simple queries to server and how fast it is responding back. And if you take the last graph which I showed you, the cloud infrastructure is able to give a performance there. And just consider what the actual Postgres is capable is, and what the performance you are going to get because of this network latency. And this is, again, last year I presented all the papers of major cloud vendors, why they consider TCP, because TCP IP is designed in 1960s for ARPANET. So all the technological changes happen, and it is not designed for a data center operation. It is for a wide area network. The TCP IP is originally designed for a wide area network. Now we try to retrofit into our data center and carrying all the overhead and all the TCP stack. And it is really aged. The architecture is really aged. And almost everyone knows it. A lot of papers are there. You can just search around. I'm not going to that. So the takeaway is latency is not improving. 20 years back we were measuring latency network latency in milliseconds. Even today we are measuring network latency in milliseconds. There is absolutely no improvement in that area. The improvement is only on the bandwidth. And what we are impacted is the latency. And how to say, if you have infrastructure, how to measure the latency or how to assess it. You can use Postgres wait events. I don't know what all tools you use. Personally, I use the PgGather. I maintain this project. I'm not insisting that you should also use it. You can use whatever you are comfortable with. But just consider measuring this client read wait event. Client read wait event means the server session is waiting for communication from client. It's not able to perform further. It's not able to proceed further. So the client read is a measure of how much time a session is waiting in between a transaction. I mean within a transaction. Say you have a update statement or insert statement came, and server is expecting a commit or a rollback or a next statement to come in. So it is waiting for something to happen. So that is the client read. And another part is the network delay, network or the delay at the server side. That means how effectively the server side connection is utilized. Say one session entered and the connection is released back to the pool. Another session need to take that connection, use it. So there is a gap between using the same connection again and again. So that is reflecting as net delay. So if the net delay is high, means the existing connections are not properly utilized. It is just sitting idle or wasting time, wasting server resources. And tools can even tell per session how much time it is wasted on this waiting for network or getting assigned to someone else. So client read, see if you look at these numbers, you can see that actual processing is very less. Say data file read, CPU time, valsing, all these are 0 point numbers. But look at the delays, 77, 12, so big numbers. So majority of the server capability is getting wasted. And this is not only for the proxies and poolers, it affects everyone. Postgres community also aware about this. That's why this query pipelining feature is introduced in Postgres. And this is not related to proxies, but a related topic to understand the complexity of the network delay. Please visit this website. This blog post is from Daniel, and he showcases how query pipelining solves some of these latencies, because pipelining allows sending multiple statements one after another without waiting for a reply. So in this chart is about local host. You can see even in a local host, in a pipeline mode, we are getting very high throughput. With no pipelining, normally applications will wait for a reply back. So the performance drops. But this, if instead of local host, what will happen if it is a network? This is the result. Actually, server is capable of doing this, what you see in the right side, but you will be getting what you are in the left side. So much of resource wastage and performance degradation. And this is another benchmark done by my friend Fernando. Actually, he was telling people to use PgBouncer, kind of external poolers, but reading between the lines, there are a lot of things we need to understand. Say, look at the graph he prepared. You see the big, tall blue bar, right? So that is the direct connection to Postgres from client. So Postgres server is capable of doing this, what you see in the right side. And it degrades because the connection management becomes poor when we have a lot of connections hitting the server. So that is where the external pooler come to play. And that gives a steady state. But to get that steady state, we are making a huge sacrifice. A lot of performance degradation happens there. And such benchmarks has a serious problem because they are saturating the things, saturating the CPUs, all those things. So that is not the real world test case we should really measure. And the latency happens in other places also. This is the authentication latency. The top part, you can see that the port is 6432. It's a PgBouncer port. And what we are getting is 97 TPS. And if you make a direct connection to Postgres, we are getting pretty much same TPS. Because in this case, we are using scram authentication. Scram authentication has a lot of overhead because there is back and forth communication. So that takes over. So the overhead of that back and forth communication takes over the entire thing and degrades the performance. So in this case, the overhead of authentication is such a high level that we are not getting any performance benefit of having a pooler. Yeah, and think about if the application is able to cache that connection locally and reuse that connection from application side repeatedly, we are going to get a much high performance like 4500. So it is the authentication overhead takes over here. And in this case, the pooler won't be able to help us because application need to go to external pooler and get authenticated. The pooler cannot accept every incoming connections. And if you are using very complex poolers like PgPool, which has a lot of features. So when we talk about anything, people talks about features. They won't talk about the overhead. So PgPooler has a lot of features, connection, the query routing, all those things. But all those features comes with a cost. So that 97 drops to 35. And the point is, more features means there is more work to do. And more work means more latency, and more latency means poor performance. So we are losing value. Say, as I mentioned, the performance is the value which we are delivering to business. So we are end of the day, we are sacrificing the value which we are supposed to deliver. And security. So next value which we are supposed to deliver, how external poolers or proxies will affect. All of you know that Postgres 18 deprecated MD5 authentication. So how many of you still using MD5 in your pooler? Yes. Yeah, so you'll be forced to remove it down the line because security audit will come and they'll say you are still using MD5. So, and as the warning message in the Postgres documentation says, it will be completely removed down the line. The community is making progress because the MD5 authentication has a lot of problems. So we can just pass the hash value and get authenticated. So if somebody steals your hash value, they can get authenticated to the server. And it is vulnerable for the brute force attack, rogue servers. And look at the last one, the man in the middle attack. Why I made it bold is, actually the external proxies and poolers are man in the middle by very design. That is a problem. So to accommodate that man in the middle, we need to make a lot of sacrifices. Okay, so Scrum authentication is a lot more complex, but it adds a lot of value. So your passwords are not getting exposed because client and servers, they are communicating each other and convincing that they knows the password without actually exchanging the password. And hashing algorithm is a lot more complex. Salt strategy is more robust. Reply protection, mutual authentication, all these things are possible with the Scrum authentication. So you have, from security perspective, a lot of advantages there with the Scrum. However, there is a cost for that. Scrum authentication has a lot of work to do. Security comes with a cost. The latency increases. In many places, latency almost doubles. And because this is the work it needs to do, the back and forth handshake, exchanging the tokens and hash values, yeah. So there is a lot of work. So a lot of work means latency. And please visit this, if you are interested in learning how Scrum authentication works, there is a beautiful blog post on that, not from me, someone else. Yeah. Additional security comes with a performance cost. And yeah, like I mentioned, when we have external proxy, which is connected to the Postgres, the application need to keep authenticating again and again and again to the pooler. It's like you are keeping your wallet in the bank locker. So every time you need to go to bank locker and get authenticated and take some money. So you are supposed to keep the wallet in your pocket so that you can immediately use it. And from security perspective, there is something called channel binding. I think all of you know. That ensures a lot more security. So because ultimately we are doing authentication using Scrum, convincing the server that I have the password. But what happens after authentication, somebody hijack the connection channel. So look like a thing like say you are inputting the pin in the ATM. Once you input the ATM, somebody push you back and take the control. So that's what happens in authentication. So channel binding means the channel which you used for authentication, that channel no one else will be able to use. So it's a secure method. And is channel binding possible with external proxies? No, because that is a man in the middle. So you are sacrificing the security. A major advantage of channel binding is you will be losing if you are using external proxies. And what about TLS verification? Of course, we can't use the certificate verification using proxies, because the client can't see the server. Client will be seeing only the proxy. So, okay, we can ask the certificate of the proxy, but what is the fun? It is someone in between. Client sees only the certificate of the proxy, and server also. Say, so think from the server perspective. Server will be keep on verifying the same proxy certificate. There is no value. And in addition to that, there are a lot more security problems. Say, there is a saying, right? A chain is as strong as its weakest link. So when we have a lot of things chained, a vulnerability in between can destroy the entire stuff. So the chain will break. So this is a recent vulnerability in PgBouncer. So I am quoting PgBouncer again and again because it's popular, and I like PgBouncer than anything else. So the problems are not specific to PgBouncer. Other poolers also have similar problems. And what about PGHPA.conf? So one of the biggest thing which we use to secure our server. So when we use external proxies and poolers, we'll be keeping or we will be accepting everything coming from that proxies and poolers. We can't really mask for the specific client. So the biggest protection offered by Postgres we are losing. And what about availability and maintainability? This is a problem which a lot of people overlook. When we have external proxies and poolers, there is high chance that there is an application tier pooler sitting in the application side, because nowadays most of the Java, .NET, everything comes with a built-in pooler. And what happens is, when application side pooler starts up, when the application starts up, it will build that pool, application side pool. And when that happens, it will establish all the connections to the database, because that application pooler thinks that it is making a direct connection to database. So all the connections will be acquired from these external poolers, and it won't release it back. And it will hold that connection until the application shut down. So basically, we are losing all the benefit of this external pooler there. The connection, say, external pooler can reuse that connection only if it is released. So it's not releasing, it is holding that. Application side pooler is holding that. And moreover, there are a lot of problems also. If the external pooler somehow try to multiplex the connection, the application side connection pooler goes mad, because it is expecting a dedicated connection. So session level things goes wrong. And at end of the day, we'll be getting poor multiplexing and session mode pooling. I don't know whether session mode pooling should be called as a connection pooling, because until the session releases the connection, it cannot be reused. Nowadays, no application releases the connection back to the pool. Earlier days, maybe some PHP or something might be doing that, but now most of the application will be establishing connection at the beginning, and it will be releasing at the end. So session mode pooling won't really help, and indirectly we will end up in session mode pooling if we are using external poolers, because application won't release the connection. And there are a lot more complexities. I cannot cover everything. And this is Jelde. So he was here in PGConf 2014. He done a wonderful, and he is a maintainer of PgBouncer. So there is a wonderful presentation about PgBouncer and its complexities. And if you missed that, please watch it. The video is available in YouTube. So please understand that will give you an idea of the complexities associated. It's not simple. Especially if you are running multiple instances of PgBouncer, there is a lot of problems. And this is another blog post by Jeremy. So when we stack pooler over pooler, if some mess up happens in one layer, we'll have a devastating effect on the next layer. So he is explaining a case where the connection got released back to the pool with a transaction open. So because none of these poolers are designed for stacking. So when we start stacking pooler over pooler without thinking about the complexity, we'll end up in this situation. So why I am quoting external stuff, the blog post and the YouTube is, I don't want to be biased about my content. So you can cross-refer what others also thinking or others also experiencing. And this is not only for the poolers of PgBouncer or the open source stuff. This is a post about RDS proxy. So any proxy, any pooler is experiencing similar problems. So people will learn these defects by really experiencing. So this is where the positive bias is causing the problem. So people talk about all the positive sides always. So look at all the presentations by Postgres vendors. They talk about all the features. We have this feature, that feature, all those things. But then they never talk about the cons. So what are the frequent problem people will be encountering? If you search in the internet also, there won't be any content about the negative sides of something. So the negative sides we need to learn in the hardest way. And AI systems also won't help because that also learns from the internet. So, and people will get frustrated and they'll put social media posts. That is one of the way we can get in touch with people. Yeah. And troubleshooting. So whenever there is a proxy in between, we won't get the IPs anywhere, whether it is pgstat activity or Postgres logs. So our ability to troubleshoot things will be affected. And another narrative which we often hear is the forking process is very complex. So Postgres is a process based, that's why we use poolers, external poolers. But is it changed? Is it still relevant? So let us check. So previously forking a process, say Linux kernel 2 and all, it's really bad because the entire process address space had to be copied. But things changed over a period of time. The Linux kernel is not something stagnant. It is going a lot of development. It's one of the major development, one of the most active open source development. And you can just write a small C code and see how many forkings can happen in a second. See, more than 10,000. So the modern Linux kernels don't have any limit there. It's 10,000 is amazing number. Say, who is going to make 10,000 connections per second to a database? So the OS level, there is no problem. Modern kernels are very efficient. And even we can fine tune the capability using some of the kernel parameters. And will that help Postgres? So Postgres has a lot of additional overhead. So it need to, the multiple processes it need to manage and memory allocations, port allocations, and there are a lot more overhead than just forking the process. So let us put that also into test. So, yeah, so from 10,000 it comes to some 2,000 levels, but still it's a big number. So no one is establishing 2,000 connections per second to a database. So the takeaway is that forking process is cheap now, or the Postgres is really able to deliver that. But when we add authentication on the top of that, it drops to a considerable part. And when we, so here, the last part, I don't know whether it's visible to backside. So in Postgres, the forking is done by the postmaster. And it's a single process. So single process is able to handle this 2,000 forkings, new connections. And there it is saturating at 97% of CPU, single core saturation. And you can get this source code from the link. So I'll be sharing the slides. You don't have to take the photos. It is available. And yeah, so so when we have authentication, it's decreasing. And when we have a network overhead, it further decreases. So what actually hurting is not the Linux capability to create process, but the authentication overhead and the network overhead. Okay, so since to debunk the myth that the thread-based the databases are even better, yeah, it's definitely better. Threads are better, but if you look at the MySQL is able to handle 3000 levels. So there is Postgres is at 2000 levels, and the thread-based systems are at 3000 levels. It's not too dramatic. Compared to the performance loss we have due to all these network overhead and authentication. And Pooler at the database side often end up with Pooler over Pooler, repeated authentication, and session level pool. These are frequent problems. On almost daily basis, I'll get some or other customer cases. So a better solution is application side pooler. So application side pooler can have all the benefits. So because first of all, it won't end up in session mode pooling indirectly. So sample code is available here. So in this case, you can see the max, the pool size I set to only two database connection. So this application is making only 2 database connection, and around more than 100 plus application sessions are using these two connections. So I pushed the limit. I am able to get at least 1:400. That is the ratio I could able to get. 400 application connections, application sessions can use 1 or 2 database connection. So that level of multiplexing we can achieve. And the source code is available. Please check it out. And if you are using Java, Spring, all those things, again, similar source code is available. You can experiment with that. So all these things are really possible. Say for HAProxy, you don't need to have all the keep alive, all those things, because there you can see the connection string can have multiple host names. So you don't have to fit all these things in front. So anyway, you are going to give a connection string to the application. So it can have multiple host names. So and there at the end you can see the server type is primary. So it will pick the primary host, primary server from the available servers. So there is no problem, it works. Yeah, and app side, there are a lot of other projects about the pooler optimization in the app side. This is for application developers. So please check it out. The links are there, discussions are there. And the end result is, say, some complex systems, they end up in using just 4 database connections. So that is what actually required. 4 database connection is what required. And here is another project, FlexiPool, for fine-tuning those application side connections. Check it out. And I am concluding with an upcoming feature in Postgres 19. So Postgres 19 has this feature for wait for LSN, a wonderful feature. We can avoid all synchronous standbys with this. But if you are using external pooler, be careful, because the wait for LSN blocks the backend process until that LSN reaches. So be careful about that if you are using external poolers. So with that, thank you all.